Okay, class, welcome back. And today we're going to continue on chapter 3, and this is going to be section 5. We're going to be talking about more conditional statements, and this is again not going to be a very long section, okay, because we're going to be doing some of the same stuff, but we're going to be talking a little bit more in depth on how to use these statements. And so we're going to look at equivalent statements, statements that have the same truth values. So we say that they're equivalent, they're saying the same thing. We're also going to look at variations of conditional statements. Okay, um, and we're going to give names to these. So the objectives is to use a truth table to show that statements are equivalent. So remember, truth tables are tools, so we're going to use this tool to help us determine the truth value of statements and to show that statements are equivalent. We're going to also learn how to write the contrapositive and the converse and the inverse of a conditional statements. Now, equivalent compound statements are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. So it says if a compound statement is true, then the equivalent statement must also be true, or if the compound statement is false, then the equivalent statement must also be false. So they have to have the same truth value to be equivalent statements. And we can use truth tables to show that. Because if we do a truth table and we have all the combinations of true, false going down the table for the simple statements, then we can compare each statement or compound statement that we're looking at. We can compare each compound statement, and if they have the same truth values going down the columns for each one of those, then they must be equivalent. So in this case here, we want to show that these two compound statements are equivalent. And so here we have P or not Q, and then we have not P implies not Q. And so all we have to do is show that these have the same truth values going down the truth table. And so we first start with our P and Q, since those are the only simple statements that are on there. We start with our combinations of true and false. So T, T, F, F, and then T, F, T, F. And then we do not Q. And so not Q is false, true, false, true. So now we have the negation of Q, FT, FT. And then we look at P or not Q. So we're looking at this column and this column. And so or, like I'm going to keep repeating, is that it's only true, or excuse me, only false when both of the component statements are false. And so in this case here, the only one that's false is this one, okay, for P or Q. But we have not Q. So we're looking at this one and this one. So you got to be careful. So we're looking at where both of these are false. True, false. So this is going to be true. True, true. So this is true. False, false. So this is going to be false. And then false, true. It's going to be true. Okay. So these are the truth values of the first one. So now we're going to do not P, because we got not P here. Now typically I would do not Q and not P and then have these two columns next to each other. Okay, but it doesn't really matter. So we have not P, which is false, false, true, true. And then we have not P implies not Q. Now this is only going to be false if this is true and this is false. So not P, these are false. So this is automatically going to be true, because when the antecedent is false, the whole thing has to be true. Okay, so this is going to be true. Now this is true, and what about not Q? Not Q is false. We have a T followed by F, so this is going to be false. And here we go. But this one is true, true, so this is going to be true. So this is the truth value for this one. Now we compare the truth values as we go down. True, 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 false, false, true, true. So they do have the same truth values going down the table. So therefore, this compound statement and this compound statement are equivalent. Okay. So now, a conditional statement and its equivalent contrapositive. Okay. So an implication. So this implication and the contrapositive, this is what we call the contrapositive of the statement, are equivalent. We said this before. Okay, so now in some symbols, we write an equivalence with the 3 bars. This means equivalent. So this statement is equivalent to this statement. Okay, so the truth value of a conditional statement does not change if the antecedent and the consequent are reversed and both are negated. So the statement not Q implies not P is called the contrapositive of the conditional. These two statements are equivalent statements and will always have the same truth values. Now, to write equivalent contrapositives, we basically flip the direction and negate both sides. So if you live in Los Angeles, then you live in California. So this is the implication. This is the conditional. Okay. If you live in Los Angeles, then you live in California. And so P is you live in Los Angeles, Q is you live in California. Now, if we want to write the contrapositive of this statement, then all we do is flip the direction, right? Flip the if and then, and negate both sides. So we would write, if you live in Los Angeles, then you live in California. P implies Q. If we flip the two sides, right? So now we're going to do Q implies P and then negate both. So we get not Q implies not P. Then what are we saying? We're saying if you do not live in California, then you do not live in Los Angeles. And these, of course, are saying the same thing logically. Okay. So now these are the different types of conditional statements that can be written. So you have your conditional, the normal conditional, P implies Q. This is called a conditional. Or if P, then Q. If we go the other direction, if we just flip the direction and say Q implies P, this is called the converse of the conditional. So if we have the conditional and we want to write the converse, we're just flipping the direction of the arrow. If we want to write the inverse, we're keeping the direction of the arrow, but we're just negating both sides. So if we want the inverse of the conditional, then all we do is negate both sides and we're done. That's the inverse. And then the contrapositive is we do both. We flip the arrow and we negate both sides. Now, conditional statements and contrapositive statements are always equivalent. But it also turns out that converse and inverse statements are also equivalent statements. So now we want to write the converse, inverse, and the contrapositive of the following conditional statement. It says, if you are 17, then you are not eligible to vote. That is a true statement. Okay. So what is the converse of that? The converse would say, if you are not eligible to vote, then you are not 17. Or excuse me, then you are 17. If you are not eligible to vote, you are 17. Well, that doesn't make sense, right? That's a false statement, right? So solution, use the following representation. So we're going to use P, you are 17, and Q represents you are eligible to vote. Okay, so we usually write the P and Q in the positive sense. So you are 17, and Q is you are eligible to vote. So this conditional is P implies not Q. Okay? So that's the conditional. Now, if we want to write the inverse, or excuse me, the converse, we just flip the sign. Not Q implies P. Okay, so we're going to first translate the symbolic form of each statement back into English. Okay, so here's the given conditional statement. The converse, which is again reverse the components, reverse the arrow. Okay, this means not Q implies P. The inverse means we're going to keep the direction of the arrow, but we're going to negate both sides. So that's not P implies Q, right? So look, we get a double negation, right? We negate both sides. We get not P, and then we get not Q. So these negations cancel each other out, which gives us P. Which gives us Q rather, okay? So that's another thing about negations is they're sort of like negative signs, right? They double, if you double them up, they cancel each other out, okay? So now we get not P implies Q. And then the contrapositive is we're going to do both of these things. We're going to flip the direction and negate both sides. So we get not Q implies not P, or Q implies not P. And so what is it saying? It says, first of all, it's that we start with the English. We translate this back into English. And it says, if you are 17, then you are not eligible to vote. So the converse is flipping it around. If you are not eligible to vote, then you are 17. And that's not necessarily true. Okay, so this is a false statement. Okay. The next one, which is the inverse, means that, hey, we're just going to negate both sides. So if we start with this, if we negate both sides, then we get, if you are not 17, then you are eligible to vote. And that's what we have here. If you are not 17, then you're eligible to vote. And that's not necessarily true. Okay. And the last one, the contrapositive, means we're going to flip the direction and negate it, which means we're going to say, if you are eligible to vote, then you are not 17. And this is the same thing as this, as is both of these are true, or not true, but both of these are saying the same thing. Okay, and that's the end. Okay, and that's the end of this video. So again, practice these, study these. We're going to practice in class, but again, remember, you still have to practice outside of class. You still have to study outside of class. Remember, for every 1 hour in class, you should be spending 2 hours outside of class. So even though we're going to be doing practicing and we're going to be doing this stuff in class, you still have to do your part and do some studying and preparing and practicing outside of class. So make sure you go through examples, go through this suggested homework. Make sure you're keeping up with the homework that we're going to be working on in class and the exercises. But make sure that you're prepared with questions and ready to jump in and start practicing when we get to class as well. So until then, have a great day.